Okay, I thought I would give you a little explanation about what systems of equations are and what you're doing when you're solving them. Because I know it's kind of tedious, and so I thought this might help you understand. So here we have a system of two equations and two variables. And remember what a graph is. A graph is a way of showing the solutions to this equation. So the red thing here, the red line here, is it shows you all the solutions to this equation, and the same with the blue, right? This one. So this point, the solution to this system, is the point that satisfies both of these equations. Okay, so when you solve a system of two equations with two variables, you're finding a point. Now, what happens when there's dependence between the two equations? So let's look at that. Okay, these two equations are dependent. And what does that mean? Well, if you look at this first one here and then the second one is the same as the first one, except you multiply by a scalar. You're multiplying by, in this case, a positive 2, right? So what does that do to the line? Well, basically, these two equations are the exact same line. They span the exact same space. So the solutions to this line are also the solutions to this line. These lines, even though they look different, are actually the same line. Now look at this third one here. If I add these two, so 1x plus 2x is 3x, etc., I get this equation, and that is also the same lines. This equation is dependent on these. And that's what and so there's an infinite number of solutions. That's what we mean when there's dependence, right? So what about inconsistent? What does that mean? Well, that means there is no point that is both on this line and this line. And so there's no solution. There's no solution to this system because there's no points on this line that satisfy this one. These are basically parallel lines, all right? Inconsistent equations in two variables. This last part I think is pretty interesting. We're going to look at systems of three variables and three unknowns. And what does that look like? Well, when you have an equation with three variables, that is the graph of a plane. Or if you graph that equation like this blue one here, these three variables, you have three dimensions, and that is a graph of a plane. So when you have three equations and three unknowns and you find the solution, what are you finding? You are finding the point where the three of these planes intersect, and there it is right there, right? This, if you can see that point there. So these three planes, there's one point that satisfies all three of these equations, okay? I have this, you can't see that, there you go. So this is a system of three equations and three unknowns. But you can also have, oh, there we go. You can also have no solutions. And what does that mean? Well, in this particular case, two of the planes are parallel. So there's no point in this space here that satisfies all three of these equations, okay? And so, let's see here. In this case, there's an infinite set of solutions, okay? And that happens when the three planes intersect in a line. So there's an infinite number of solutions here because the three planes actually intersect in a line. And every point on that line, which the line's infinitely long, satisfies all three of those equations. So that's what systems of equations are. Basically, you're finding a point of intersection, and if you find an infinite number of solutions here, that means that there's some dependence here. Or if you can't find any points of intersections, typically that means the lines are parallel, or the planes are parallel, or they just don't have an intersection point. So I hope that helps you understand what you're doing. I know it's tedious to do these things, either with elimination or substitution, but I really kind of would rather you understand what's going on when you do that. So hope that helps. Bye.